Hello everyone, I am Syed Tazen Ali from Electronics and Communication Engineering branch, Bundelkhand University, Jhansi. Today we will discuss about the topic of network theorem, which is subject of electrical engineering. Today we discuss about the theorem. Actually, theorem is used to simplify the network, and so that we can easily calculate the current and voltage in particular branch. So, first theorem is superposition theorem. In this theorem, the any linear bilateral two terminal network consists of more than one sources. The total response in any part of a network is equal to the algebraic sum of the response in the required branch, with each source acting individually while other sources are inoperative. Inoperative means the other sources which is independent, either a voltage or current source. The voltage source are short circuit and the current source are open circuit. So, let us discuss about the superposition theorem in detail. Now, so let us start the basic of the superposition theorem. Now, this theorem is used for more than one energy sources for calculating the response in any particular branch of the network. So, we have to calculate the superposition theorem through this process. So, let us start with the basics. Suppose this is the network which have 8 volt so voltage source in series with the 2 kilo ohm resistance, and the 5 volt voltage source in series with the 4.7 kilo ohm series resistance, and here is a load which is a 3.3 kilo ohm. Here we find the value of VR in particular branch using superposition theorem. So, we just calculate the current first and then voltage, then calculate the voltage. So, let us start with the topic. Suppose we have redrawn the circuit here. This is 8 volt in series with a resistance 2 kilo ohm, and here is a load where we find the current and then a voltage which is 3.3 kilo ohm. Here is another source which is 5 volt in series with the resistance of 4.7 kilo ohm. So, all resistance are in kilo ohm, and here we find the current, overall current. So, according to superposition theorem, we first activate the 8 volt voltage source and then short circuit the 5 volt, and then we have calculated the current at 3.3 kilo ohm, and then we have another process in where 8 volt source is short and 5 volt is activate, and then we find the current. According to the superposition theorem, we have just algebraic sum of the current and then find the total current of both the sources, that is a superposition theorem. So, let us start. So, first we have use 8 volt source only. So, by that 5 volt is short circuit. So, just redrawn the circuit here, which is 8 volt and resistance is 2 kilo ohm. This one is a 3.3 kilo ohm and this one is 4.7 kilo ohm, and this one is a short circuit. So, if we see the circuit, this is the first procedure for superposition theorem, and here we see that 4.7 and 3.3 are in parallel, and this combination is in series with the 2 kilo ohm. So, for finding the this total resistance, this one is parallel, it means 4.7 into 3.3 upon 4.7 plus 3.3 plus 2 kilo ohm. This is equivalent resistance R equivalent, and this value is around 4.7 into 3.3 divided by how much is it is around 8 kilo ohm, 8.0, and we have cancelled out the value here. The required resistance will be around 4 to the 8 2.5, this 3.7 kilo ohm. So the net equivalent resistance is 3.7 kilo ohm. Now this equivalent circuit is considered again is like this 3.7 kilo ohm, and this one is a 8 volt 2.2 milliampere. So where we find here this current is suppose I1 and this direction, and the total current from this battery is 2.2 milliampere. Now this current is divided into I1 dash and I1 double dash. So by using a voltage by using a current division rule, we can find the current in 3.3 kilo ohm resistance, which is around 3.3 sorry 4.7 divided by 3.3 plus 4.7 into total current 2.2 milliampere. This is around 4.7 upon 8.0 into 2.2 milliampere. So I1 dash equals to is 4 to the 8. This is around 1.05 milliampere. So current using 8 volt source at 3.3 kilo ohm will be 1.05 milliampere, and it is the direction of this current is downward. Let's store this current, and we have to use another source and short circuiting this 8 volt voltage source and activate the 5 volt. So by activating the 5 volt and short circuiting the 8 volt source, we can find the current at 3.3 kilo ohm. Okay. Now again the same procedure is revised, where we find the net current, which is I2 from the source, and then I2 dash at 3.3 kilo ohm resistance. Okay, so for finding the I2, we just simplify the resistance by using parallel and series method. So 2.2 and 3.3 are in parallel, and then the whole equivalent value is series with the 4.7 kilo ohm. So R equivalent dash equals to 2.2 k into 3.3 k upon 2.2 k plus 3.3 k, and the whole value is in series with the 4.7 k. So we just calculate this value and add it. So this is around 5.5 2.2 K into 3.3 K. So cancel out. 11 to the 24, 11 to the 55, 5 6 is 30, 5 6 is 30. So 2 6 is 12, 2 6 is 12, 1 13. 13.2 kilo ohm. The net equivalent resistance is 13.2 kilo ohm, and by using Ohm's law, we can find the current at from the source, which is I2. Now 5 divided by 13.2. Okay. So it is around 50 upon 132 milliampere. So point it is around 389 milliampere. So 0.389 is emerged from the source of 5 volt. Now using current division rule, we can find the current here at 3.3 kilo ohm resistance. So which is I2 dash, and for this the formula is 2.2 K divided by total resistance 2.2 K plus 3.3 K into total current 0.389 milliampere. Now the I2 dash is 2.2 K upon 5.5 K. So cancel out this symbol and into 0.389. This is 0.4, 40%. This is around 0.1566. This is 1566 milliampere current from the 3.3 kilo ohm. So as we see that the first from 8 volt source, the current at 3.3 K will be is around I1 dash. Where is I1 dash? Here. 1.05 milliampere. Okay. Now for 5 volt source, considering the 5 volt source, the current at 3.3 K is 1.1566. So we see that the direction is downward on both the considering the source. So we just adding the value. So I equals to I1 dash plus I2 dash, because both direction are same. Now the I2 dash is 0.1566 milliampere and the value of I1 dash is 1.05 milliampere. So net value is around 1.2066 milliampere. So this is the current according to superposition theorem from both the sources, considering at the same time. So we can calculate this current using superposition theorem.